Good morning, all of you. Okay, good morning, all of you. Are you hearing my voice? Are you hearing my voice? Okay, right. In different cases, already yesterday I said no. In different cases, I make a video and I will upload in the YouTube. Okay, I made a video. That means different derivations for solid sphere, hollow sphere, solid sphere, hollow sphere. Okay, in different cases, I derived the formulas for moment of inertia, and today afternoon I will upload in the YouTube. Okay, so that you can see them. Okay, but we are having only formulas, but in order to know how we got that formulas, I derived. Okay, so that approach is important for advanced exams. That's why I derived them. So today afternoon I will upload in the YouTube. Okay, yesterday I completed the ring. Moment of inertia of the ring in different cases I completed. The disk also completed, no? No, sorry. Disk is not completed. Okay. Here, just I will explain what is the moment of inertia of the disk about different axes. I will explain, but I don't want to derive because already I derived in the video. I uploaded today. I will upload in the YouTube. Okay. Up to rod already I said yesterday. In ring is also over yesterday. Okay. Today, just I will explain what are the formulas for moment of inertia in different cases, but I derived the formulas in video. So you can go through, because if I derive now itself, there is no time is wasting. Because in IP also, they don't ask the derivations. We are having only formulas. Okay. How many pages you have to leave means I cannot say. At least I think 3-4 papers. 3-4 papers you have to leave. Okay, Sriram. Right. I will explain briefly. Directly, I will explain. Moment of inertia. Moment of inertia. Already, first case, thin uniform rod is over. Thin uniform rod, that is completed. Next, thin uniform ring is also completed. Thin uniform ring, that is also completed. Okay. Next, okay, these two are completed, I think. These two are completed, I think. Okay. Now, third one. So, uniform circular disc. Uniform circular disc. In case of uniform circular disc, first one, about which axis moment of inertia to be determined? About natural axis. About natural axis. About natural axis means, suppose you see, this is the circular disc. So from sidewise view of the disc is like this. Sidewise view I am showing here. Okay. Mass of the disc is say M and radius is capillary. Center is say O. It is the radius capillary. Center is O, radius capillary. Okay. So here, about an axis passing through center and perpendicular to plane of the disc. The line passing through center and perpendicular to plane of the disc is called the natural axis of the disc. About this axis, what is the moment of inertia? I. Okay. Here, it is not the circular ring. In case of circular ring, already we derived the formula. About natural axis of the circular ring, what is the moment of inertia? mr square only, no? About the natural axis of the uniform ring, the moment of inertia is mr square. But here it is the disc, it is not the ring. That's why here this disc can be imagined as the combination of number of circular elements, no, like this. It is one circular ring. Number of circular rings we can imagine from center to up to periphery of the disc. Center దగ్గర నుంచి periphery వరకు అంటే edge వరకు ఇట్లా number of rings లాగా imagine చేస్తే We can imagine the circular disk as the composition of the number of circular rings with concentric centers. With concentric centers. Okay. So here, so disk can be imagined as the combination of number of concentric circular rings. Okay, for one circular ring, you find the moment of inertia. Then you integrate between radius of the ring from 0 to capital R. Then you will get the moment of inertia of the entire disk about this axis. You will get I is equal to mr square by 2. Mr square by 2 you will get. So about the natural axis of the disk, what is the moment of inertia means mr square by 2. Already, yeah, I derived totally by considering the element. I derived the moment of inertia of the element about this axis. Okay, and I integrated, and whatever the value I got here, that was derived in the video. So you can go through video. Okay, if you need. Next, this is the moment of inertia of the disk about the natural axis. Okay, next, about the diametric axis, what is the moment of inertia? B. About the diametric axis means, suppose this is a circular disk. About this diametric axis, what is the moment of inertia? We have to find. I is equal to question mark. Okay, here it is also the diametric axis, no? Diametric axis means the axis passing through center and lies within the plane of the disk. That is called diametric axis. The axis or the line passing through center and lies within the plane of the disk. That is called axis of diametric axis of the disk. Okay. So this is diametric axis. This is diametric axis. Suppose this is a x-axis. This is a y-axis. These two are the diametric axis only, no? About this axis, that means about z-axis we know. About z-axis we know the moment of inertia, because z-axis acts as the natural axis as here. That's why about z-axis moment of inertia Iz is equal to mr square by 2. About this axis, about diametric axis of the disk, what is the moment of inertia? As this is the diametric axis, this is the diametric axis. About these two axes, moment of inertia is same. Okay. Now we apply the perpendicular axis theorem. According to the perpendicular axis theorem, the moment of inertia of the disk about the z-axis, which is passing through the intersecting point of the two perpendicular axes, lies within the plane of the disk, is equal to, that means Iz is equal to Ix plus Iy. As Ix, Iy both are same, we can write, instead of Ix you write Iy is equal to I, Ix is also equal to I. That's why 2I we can write. It is Iz. So 2I is equal to Iz means mr square by 2. Therefore, I is equal to mr square by 4, no? Therefore, moment of inertia of the disk about the diametric axis is equal to mr square by 4. About the tangential axis lies within the plane of the disk. About the tangential axis lies within the plane of the disk, what is the moment of inertia? It is the tangent drawn to the surface of the, it is the tangent drawn at the periphery of the disk, but lies within the plane of the disk, like this. Okay. Now about this axis, what is the moment of inertia means? Here, to this axis, parallel to this axis, passing through center of mass, already we know the moment of inertia about this axis, that is Iz. About this axis, what is the moment of inertia means mr square by 4 only, no? So that is equal to mr square by 4. The perpendicular distance between two parallel axes, small r, is equal to radius of the disk only. Then according to parallel axis theorem, about this axis, moment of inertia is equal to Iz plus mr square. Iz means mr square by 4 plus mr square. M into r square means perpendicular distance between two axes square means capital R square only. So 5 mr square by 4. So this is the moment of inertia about the tangential axis lies within the plane of the disk. Sometimes they may ask moment of inertia of the circular disk about tangential axis perpendicular to the plane of the disk. They may ask perpendicular to the plane of the disk. They may ask. That means in the next case here, D. This is the disk. It is the center. It is the tangential axis only, but this is the tangential axis perpendicular to plane of the disk. About this axis, what is the moment of inertia? They asked. Okay, parallel to this given axis, passing through center of mass, we know the moment of inertia. About this axis, moment of inertia is equal to mr square by 2 only, no? Because it is the natural axis of the disk. The perpendicular distance between the two parallel axes is equal to capital R. Small r is equal to capital R. So you apply the parallax theorem. According to that, I is equal to Iz plus Iz means mr square by 2 plus m into r square means this r square. So 3 mr square by 2, no? 3 mr square by 2. This is the moment of inertia about this axis. Sometimes you will be given, you may be asked, suppose this is a circular disc of radius capital R, mass capital M. About the card, about one card, what is the moment of inertia? This is the card of the disc, circular disc. Okay. Here about this card, what is the moment of inertia? I. That is the question mark. Here this card is at a distance smaller. The smaller will be given. Small r is equal to half of the radius or 1/3 of radius, like that it will be given. What is the moment of inertia of this disc about this card, which lies within the plane of the disc? Okay. Parallel to this axis, passing through center of mass or center of gravity, we know the moment of inertia. Apply the parallax theorem. Then about this axis, moment of inertia I is equal to Iz plus mr square. Iz means about the diametric axis, moment of inertia of the disc, mr square by 4 plus m into this perpendicular distance square, that is small r square. Small r means r by 2 whole square, r square by 4. That is equal to mr square by 2 you will get now. So moment of inertia about this axis is mr square by 2 when perpendicular distance between the two parallel axes r by 2. What is the radius of gyration about this axis? Immediately about this axis, if they ask the radius of gyration about this axis, you find the moment of inertia, make them equal to mass of the system, means only one disk is there, m into radius of gyration square. Then you will get k is equal to r by root 2, no? Cancel. So k is equal to r by 2. It is the radius of gyration. It is the radius of gyration. Okay. Y I is equal to Ix is equal to Iy means, suppose this is the disk. It is the x-axis, it is the y-axis. Here this axis and this axis both are symmetric about the disk, no? This is the diametric axis, this diametric axis. This axis paranga moment of inertia of the disk anna about this axis anna okate kada. Kabatti Ix, Iy rendu equal avutayi. Whatever the formulas, both are equal. That's why I made equal. Okay. ఇక్కడ D లోనేమో tangential axis ఇట్లా ఇచ్చాడు. అంటే tangential axis lies within the plane of the disc. ఇక్కడేమో tangential axis perpendicular to plane of the disc. That is the difference. Okay. Next. Next one, solid sphere. Here about the diametric axis or natural axis. About diametric axis or natural axis of the solid sphere. Suppose this is the solid sphere like cricket ball, shot put, etc. The line passing through center of the solid sphere, that is called the diametric axis or natural axis, because in case of solid sphere, the line passing through center of the solid sphere is the diameter. That's why that can be called as the diametric axis also. That is also called as the natural axis also. No, already this derivation was recorded. Rutvik Shiva Manikanta, this video was recorded. I will upload in the YouTube afternoon. Okay. ఇవన్నీ కూడా ఇప్పుడు చెప్పాయని కూడా రికార్డ్ చేసి ఆల్రెడీ డెరివేషన్స్ కూడా రికార్డ్ చేశాను నేను. సో నౌ నో నీడ్ టు రికార్డ్ నౌ. రైట్. About this diametric axis, what is the moment of inertia they asked? I is equal to question mark. Okay. So in this case, you see here this solid sphere can be imagined as the common. Suppose you divide this perpendicular to this axis, you divide the solid sphere into number of slices like this. నెంబర్ ఆఫ్ స్లైసెస్ కి డివైడ్ చేయండి. వాట్ ఈస్ ద షేప్ ఆఫ్ ది ఈచ్ స్లైస్? వాట్ ఈస్ ద షేప్ ఆఫ్ ది ఈచ్ స్లైస్? What disk? Yeah, very good. Disk. Shape of each slice is equal to disk. That's why this solid sphere can be imagined as the combination of number of disks having different radii from center O. From center O at a distance y. When you imagine the disk, it is having radius say x. Okay. Here up to y is equal to capital R, y is equal to plus capital R. Here suppose the center is say origin. Up to y is equal to capital R, we can imagine number of disks. Here in lower side, up to y is equal to minus R also, we can divide number of disks like this. That means this type of circular disks can be imagined from y is equal to minus R to y is equal to plus R. Okay, for this disk, you find the moment of inertia of the this disk about this axis, and you integrate between minus R to plus R. Then that gives the moment of inertia of all the disks. Imagine from minus R to plus R. That gives the moment of inertia of entire solid sphere. Okay, in this way we can find. Next, for the same solid sphere about this axis, what is the formula you will get? About this diametric axis or natural axis, moment of inertia is equal to, because this is the axis passing through center of gravity or center of the sphere, center of mass also. That's why it is Iz is equal to 2/5 mr square. 2/5 mr square. What is the radius of gyration of the solid sphere about this natural axis or diametric axis means? That is equal to mk square. K is equal to root 2/5 into r. About this axis, about this tangential axis, what is the moment of inertia? Means I is equal to Iz plus m into capital R square. I means this one plus mr square. You simplify them, you will get answer. Next, hollow sphere. Fifth one, hollow sphere. Diagram is same. Hollow sphere. In case of hollow sphere, about the diametric axis, what is the moment of inertia? This is the hollow sphere. Okay. About an axis passing through center. Whatever the line passing through center, that is the natural axis or diametric axis. About this axis, moment of inertia is say I. What about that I? Here also, you imagine it is composed. Suppose you imagine perpendicular to this axis, you divide this hollow sphere into number of slices. Then what is the shape of each slice? What is the shape of each slice? Ring. Very good. That logic we have to know. When the hollow sphere is divided into number of slices, then each slice is just like a ring. That knowledge we need. That's all. That imagination every physics student needs. Then only we can do answer. Okay, very good. So here, in case of hollow sphere, mass is distributed only on the surface, no? In case of hollow sphere, mass of the hollow sphere distributes only on the surface of the sphere. Mass m is resides only on the surface of the hollow sphere, not inside the hollow sphere. But whereas in case of solid sphere, mass distributes entire volume. Here mass distributes only on its surface. That's why this is having surface density sigma is equal to mass by area of the sphere 4 pi r square. But here the mass distributes entire volume. That's why it is having volume density rho. Rho is equal to mass by volume 4/3 pi r cube. That is the volume of the sphere. Now, what is the volume of this element? Dm. Volume of this element is how much? Means dm is equal to volume of this disk into density. Volume means as the radius is x, pi x square is the area of cross section into thickness is this thickness approximately. This is equal to say dy, because y e direction distance y distance కాబట్టి అదే direction width, that is say dy. That's why area of cross section pi x square into thickness dy, that is the volume, into density gives mass. That is the mass of this circular element here. Similarly, at this case, what is the mass? Means the mass resides only on the surface. That's why surface area we have to take. So to find the mass of the element here, the surface area, radius is say x, this is at a distance say y. Okay, here at this point you see here, at this point the width is say dy. Width is dy. Okay, therefore mass means area of the element. Area of the element means circumference is equal to 2 pi x into width is equal to dy. That is the surface area of the element into surface density sigma. అంటే యూనిట్ ఏరియాకి ఎంత మాస్ ఉంటే this much area. What is the mass for this much area? That means into this one. This is the mass of the element. Okay. So mass of the circular element is known. So moment of inertia of the circular element about this axis di is equal to mr square only, no? Mass of the element dm into r square means x square. You convert this x in terms of y because this is equal to r. This is r. Okay. Then this can be written as, in terms of y, we can write square root of r square minus x square. We can write, no? Instead of x, we can write square root of r square minus y square. Instead of x, we can write. Okay. Then this type of elements can be imagined from x is equal to, y is equal to minus r to plus r. Between minus r to plus r, you integrate them. Then we'll get moment of inertia about this axis as 2 by 3 mr square. 2 by 3 mr square. About diametric axis or about tangential axis, what is the moment of inertia? I is equal to Iz plus, because this is the axis passing through center of mass or center of gravity. That's why I is equal to Iz plus mr square. Iz means 2 by 3 mr square plus m into this distance means r only, r square. That is the moment of inertia of the hollow sphere. In this way, we can find the moment of inertia of the hollow sphere. Okay. For solid sphere, mass is divided entire its volume. That's why mass by volume, mass by 4/3 pi r cube. In case of hollow sphere, mass resides only on the surface. That's why surface density is there. Mass per unit area we have to consider m by 4 pi r square. Okay. Mass of the element means, in this case, in case of hollow sphere, as mass distributes only on the surface, then what is the area of this element? Area means this length of the element means circumference 2 pi x because radius is x into width dy. That is the surface area. 2 pi x into dy is the surface area. Unit area ki enta mass unte inta area ki enta mass untundi. For unit area, this is the mass. Then what is the mass per this area? Means into sigma. That gives the mass of the element here. Into so moment of inertia about this axis is equal to mass of the element into radius square. Because moment of inertia of the circular ring about natural axis is equal to mr square only, no? So m into radius square means x square. In this way, we can do. Okay. Raven, what is your doubt? What is I? I is the moment of inertia, no? I is the moment of inertia. Okay, Raven. Yesterday we discussed it. Today I discussed it. Number of times I use it. I is the moment of inertia about this natural axis like that. I is the symbol, moment of inertia. Okay, next. Here, cone, solid cone. Suppose this is the solid cone. The mass distributes entire its volume. About the natural axis of the solid cone, what is the moment of inertia? About this axis, what is I? Radius is capital R. Height of the solid cone is equal to small h. Okay. Here also you imagine this solid cone as the combination of number of suppose you divide this solid cone into number of slices perpendicular to axis. Then what is the shape? What is the shape of the each slice? It is the solid cone. What is the shape of each slice? What is the shape of each slice? It is a solid cone. Material is there inside the cone also. When you divide number of slices, it is the disc. Yeah, it is the disc. Okay. So about this axis, moment of inertia of the disc you find. Here from this vertex, this disc is this element is considered at a distance say y, whose thickness is equal to dy. Okay, then you find the moment of inertia of the disc about this axis. Then you integrate between the limits y is equal to 0 to y is equal to h. Then that gives the moment of inertia of the all the disc from vertex to base. That you add, integration means addition only. That gives the total moment of inertia about this axis. So in case of solid cone, already in video I recorded that procedure. You go through that procedure. So moment of inertia of the solid cone is equal to 3 mr square by 10. About this axis, moment of inertia is equal to 3 mr square by 10 you will get. If it is the hollow cone, then moment of inertia is equal to. If it is the hollow cone, when you divide the cone into number of slices, what is the shape of each slice? What is the shape of the slice? If it is the hollow cone, now the ring, it is the ring. Okay, about in case of slice, the mass distributes only on the surface of the cone. Actually, what is the volume of the cone? 1/3 pi r square h, no? So mass by that volume 1/3 pi r square h gives volume density. That is the mass per unit volume. For this much volume of the disk, what is the mass you find? That is dm. So moment of inertia of this disk about this axis is equal to dm into this radius square by 2, no? Dm into x square by 2. Then integrate them, you will get answer. Next, in case of hollow cone, it is the ring. Mass distributes only on the surface of the ring. Mass distributes only on the surface of the cone. That's why here, while finding the mass of the element here, mass of the element dm is equal to surface area. Surface area means circumference is equal to 2 pi x into width. Actually, we can take the width here, but it is not the disk, it is the ring. Mass distributes only on the surface. That's why even actually you see here, width means we are taking the width like this. This is the width. Actually, the shape of the ring is like this at the edge. It is like this. This is dl, this is dy. We are taking width like this one. As the mass distributes only on the circumference, if you take like the width of the disk as width of the ring as dy, then it is having more length actually, because mass distributes only on the surface. Mass distributes only on the surface. That's why accurately we have to measure the length of this width of this element. dl we have to find. Suppose this was semi-vertex angle is say theta, then cos theta is equal to, we can write dy by dl. Then width dl is equal to, dl means we can write dy by cos theta, or dy secant theta we can write, no? That is the mass of the, that is the area of the element into surface density sigma. What is the area of the cone? Surface area of the cone is pi r l, no? Pi r into l. R is the base radius, l is the length of the inclined surface. Therefore, mass by surface area of the cone, that is the surface density. So for this area, what is the mass means? Surface area of the element into surface density. That is the mass of the element. Now moment of inertia of the element di is equal to mass into, this is the axis. This axis acts as the natural axis for this ring, no? That's why dm into radius square. Radius here is say x, so x square. Now from this right angle triangle, tan theta is equal to x by y. That tan theta is equal to r by h. So by using that value, x is equal to something you substitute here. You integrate between the limits y is equal to 0 to y is equal to capital H, small h. Then that gives the moment of inertia of this cone about this natural axis. After simplification, you will get here, in case of hollow cone, you will get mr square by 2 only. Mr square by 2 only. You will get mr square by 2 only. Okay. Okay. In this way, for different cases, we can write the moment of inertia. Up to this video is made. Okay, you can go through them for clear, detailed derivation. Okay, next, suppose we are given moment of inertia only, some other cases, moment of inertia only. Moment of inertia. This is only another case. Another case means say seventh one. Seventh or eighth, I think, number. Here there is a solid hemisphere. There is a solid hemisphere. Here there is a solid hemisphere. Here there is a solid hemisphere. It is the solid hemisphere. It is the symmetrical axis. Okay, radius capital R. Mass of the solid hemisphere is capital M. Mass of the solid hemisphere is capital M. Then they asked, what is the radius of gyration about this line? What is the radius of gyration about this PQ? Radius of gyration about PQ. Radius of gyration KPQ is equal to question mark. How we can do? Okay, how we can how here we see there is a solid hemisphere, okay, of radius r and mass m. M is the mass of the solid hemisphere only, not total solid sphere. M is the mass of the solid hemisphere only. About this axis parallel to diameter. This is the diameter now. Parallel to diameter about this axis, what is the radius of gyration they asked. To find the radius of gyration about this axis, first we had to find the moment of inertia about this axis. Moment of inertia about this axis. How we can find? Anybody else? How we can find in this case? How we can find moment of inertia about PQ? How we can find moment of inertia about that PQ? Suppose if you imagine another hemi-solid sphere like this, another hemi-solid sphere like this. You imagine another hemi-solid sphere like this. Now it becomes a solid sphere having mass 2m, isn't it? Here, solid sphere totally. When you imagine the another solid hemisphere and you keep like this in reverse order, then this total, when they are put in contact, it becomes entire solid sphere now. What is the total mass of the solid sphere now? Total mass of the solid sphere is equal to 2m. Total mass of the solid sphere is equal to 2m. Okay, now what is the moment of inertia of this diametric axis of the entire solid sphere? Moment of inertia of the solid sphere, moment of inertia of entire solid sphere about this axis, about this diametric axis is what? 2 by 5 mr square. No, sorry, it is the solid sphere. In case of solid sphere, what is the moment of inertia? 2 by 5 mr square. No, so 2 by 5 into mass of the entire solid sphere is 2m. General formula. First you write general formula. Mass of solid sphere, say small m, that is equal to 2 into capital M. No? Therefore, about this axis, moment of inertia is, you see, moment of inertia of this hemi-solid sphere about this axis. Moment of inertia of hemi-solid sphere. I am writing for hemi-solid sphere only. Moment of inertia of hemi-solid sphere about AB is IAB. That IAB is equal to how much? So IAB is equal to, you see, about the entire solid sphere, you find the moment of inertia about this axis and you make them half. That gives the moment of inertia for the remaining part. No, that's why moment of inertia of the hemi-solid sphere about this axis is equal to moment of inertia of the entire solid sphere about this axis by 2 gives moment of inertia of this part only. Moment of inertia of the entire solid sphere is general formula is 2 by 5 small m r square by 2. So this is equal to, of course, 2 cancel. So 1 by 5 into mass of the entire solid sphere is equal to 2 into capital M into r square. Therefore, that is equal to 2 by 5 mr square only. No, 2 by 5 mr square only. So moment of inertia of the hemi-solid sphere about this axis is equal to 2 by 5 mr square. This is equation 1. Okay, now is it the axis passing through center of mass or center of gravity of the hemi-solid sphere? In order to find the moment of inertia of the hemi-solid sphere about this axis PQ, if you know the moment of inertia of the hemi-solid sphere about an axis passing through center of mass or center of gravity of the hemi-solid sphere, then we can find moment of inertia about this axis. But here, in case of hemi-solid sphere, center of mass lies somewhere here, no? Center of mass lies somewhere here. In case of hemi-solid sphere, at what distance center of mass lies from the center? In case of hemi-solid sphere, at what distance center of mass lies? 3r/8, no? In case of hemi-solid sphere, center of, yeah, very good. In case of hemi-solid sphere, the center of mass lies at a distance 3r/8 from the center of the hemi-solid sphere. In case of hollow sphere, where it lies? In case of hollow sphere, where the center of mass lies from the center of the hollow sphere? That is r/2, no? That is r/2 in case of hollow sphere. Okay, so this is 3r/2, 3r/8. So if you know the moment of inertia of this hemi-solid sphere about this axis passing through center of mass parallel to this axis, this is a CD. So this is the axis passing through center of mass and parallel to given axis. If we know the moment of inertia of hemi-solid sphere about this axis, then we can find IPQ. Our aim is we had to find the moment. Our aim is we had to find the moment of inertia of this hemi-solid sphere about this axis. So for that we need the moment of inertia of the hemi-solid sphere parallel to this axis passing through center of mass. That means ICD we need. ICD means this is that is equal to IG also. This is the moment of inertia of the hemi-solid sphere about an axis parallel to this given axis passing through center of mass. We need that one to find IPQ. Our aim is we had to find moment of inertia about the chord. IPQ we had to find. So how we can find ICD about this axis? You see here about this axis already we know the moment of inertia, that is IAB. Okay, in order to find the moment of inertia about this axis, IAB according to parallax theorem, IAB is equal to IG plus M into this distance square we can write now. According to parallax parallel axis theorem, moment of inertia about this AB, that means IAB, is equal to moment of inertia about an axis parallel to this axis passing through center of mass, means this axis only, no? That's why IG plus M into perpendicular distance between the two parallel axis square means y square. So IG means about this axis moment of inertia we have to find, that is ICD, plus M into y means 3r/8, square is there, 3r/8 whole square. IAB means already we got, IAB is equal to 2/5 m r square, 2/5 m into r square. Therefore ICD is equal to IG. Moment of inertia about an axis passing through center of mass or center of gravity is equal to, IG is equal to, tell me, 2/5 m r square. Bring this to left, then 9/64 m r square, no? 9/64 m r square. Therefore, when you simplify them, then you will get, what is the value you will get? ICD is equal to IG, that is equal to, take LCM, 5 4s are 20, 32 you will get. 64 into 2, that means 128 m r square, minus here 64 5s are, that means 5 into 9, 45 m r square when you take LCM. Then ICD is equal to IG, that is equal to 128 minus 45, that means 83, no? 83 m r square by 320. This is equation 2. This is the moment of inertia of the hemi-solid sphere about this axis. Okay, when you know the moment of inertia about this axis, then again you apply the parallax theorem for this axis. Okay, again from parallax theorem, IPQ is equal to, that means moment of inertia about the given axis is equal to moment of inertia of the same body about an axis parallel to given axis passing through center of mass, means ICD. IG is equal to ICD. IG plus M into small r square. Small r square means distance between these two axes square, small r square. So mr square. Again, you apply the parallax theorem. This is equal to Iz means already we got 83 m capital R square by 320 plus m into. What about this one? What about this distance? I think that distance is given in the problem. That distance is given as 3r by 4. This distance is given by them only. This distance is given by them only. That is 3r by 4 is given. 3r by 4. Yeah, 3r by 4 is given. If here, what is the radius of gyration of the hemisolid sphere about this axis, which is at a distance 3r by 4 from the center? Means this distance is given by them only. If it is given by them, then what about the smaller? What about the smaller? What about the smaller? 3r by 4 minus 3r by 8. Okay. So 3r by 4 minus 3r by 8. That is smaller whole square. Therefore, IPQ is equal to 83 mR. Okay, you simplify them. After simplification, what is the value you will get? Okay, when you simplify them, you will get 2 by 5 mR square only. After simplification, you will get 2 by 5 mR square only. IPQ is equal to, you will get 2 by 5 mR square only. Here they asked the radius of gyration. That's why this is equal to, you make them equal to half m into kpq square. Mm cancel. Therefore, kpq is equal to root 2 by 5 into capital R. No, this is the radius of gyration about this axis. So radius of gyration about that axis is equal to root 2 by 5 capital R. Yeah, that is the answer. So this method is important. In this way we have to do. So suppose if it is the hollow hemisphere, in such case the central mass is at a distance r by 2. This distance we have to take r by 2. From this distance, if you subtract this r by 2, then you will get this distance. By following the same procedure, using the formulas, relevant formulas, we can find the radius of gyration about this axis. In this way we had to do. Okay. Next, 8th one or 9th one? What is the next note point? 8th or 9th? I think a 7th I have written. Okay, next 8th one. So moment of inertia of the circular disc of inner and outer radii are given. Moment of inertia of annular ring. Annular ring means annular disc. Annular disc means at the middle there is a hole. That means annular disc is like this. It is the center. Inner radius is smaller, outer radius is capital R. Mass capital M. For this moment of inertia of the annular disc about an axis passing through center and perpendicular to the plane. What is the moment of inertia? That means here you see, this is the annular disc about an axis passing through center and perpendicular to plane. About this axis, what is the moment of inertia? They asked. That is the question. So if you see the diagram, we can see it like this. Okay. Inner radius means this one. This is smaller. This is capital R given. Mass is capital M. How we can find? Here This is not the circular ring, no. In case of circular ring means the inner radius and outer radius both are same because thickness is very small. In case of circular ring, inner radius and outer radius both are same. That's why in case of circular ring, about this axis, what is the moment of inertia means simply we can say mr square. But here it is the annular disk. Annular disk means the inner radius is given, outer radius is given. In this case, what is the moment of inertia? So how we can find? For this, you imagine there is a small circular element. You see, I will show the diagram here. You imagine it is the combination of number of circular rings. Such type of one circular ring I will show here. Suppose the radius of the circular element considered. This is the circular element. This is a circular element whose radius is say small a and width is say b. No, width is dA. Width is dA. Mass of the circular element considered is say dm. Okay, then here you see the mass of the disk m distributes uniformly over its surface area, no? So it is having surface density. So in case of plane, in case of any body having plane surface, their mass is distributed uniformly over its surface. In case of the solid body, solid means in case of the body is having some volume, considerable volume, then it is having volume density. Okay. So here, first you consider the small element. First you consider the small element as shown here. Small element whose radius is a and width is dA. It is just like the circular ring, no? About this axis, what is the moment of inertia? We have to find. As in case of circular annular disk, the mass distributes over its surface. Then it is having surface density. So what is the surface density of the annular disk? Surface density. Surface density sigma is equal to mass by surface area. What is the surface area of the annular disk? Where mass lies? Surface area of the annular disk means from this total area, you subtract the area of the whole. That gives the area of the material of the annular disk only, no? That's why area of material of the annular disk means pi into capital R square minus small r square. So on this area only, this mass is distributed in the annular disk. So what is the mass per unit area? Means m by this one, no? Yeah, you are correct, Parshit Reddy. Okay, it is the mass per unit area or surface density. Now, what is the mass of the element considered? Mass of the element considered is say dm. Mass of the element is equal to area of the element into density. Sigma into area of the element dA. That is called sigma into, sigma is constant, you keep aside. Area of the element means here the radius of the element considered is a. Okay, that's why circumference is equal to 2 pi a, no? 2 pi a into width dA. That's why 2 pi a into width dA. This is the area of the element. So sigma into area of the element gives mass of the element considered there. Mass of the element considered there. Okay, therefore, moment of inertia of this circular element about this axis. As this element is in the form of circular ring, it becomes the natural axis for the circular ring. That's why moment of inertia of the circular element considered here is equal to mass into radius square, mass dm into radius of the ring square means a square. That is equal to dm means sigma into 2 pi a into dA into a square is there. So a square. Okay, therefore 2 pi sigma into a square. That means a to the power of 3 into dA. It is the moment of inertia of the circular element considered. This type of circular elements can be imagined from radius a is equal to small r to capital R, because these elements can be imagined from radius small r to capital R only. That's why integrate between small r to capital R. Therefore, total moment of inertia about this natural axis is equal to integral di, integral moment of inertia of the element. So this radius of this element can be imagined from this radius of this elements can be imagined from radius a is equal to small r to capital R. That's why a is equal to small r to capital R, you integrate. That is equal to integral di means 2 pi sigma into a cube dA. When you consider number of elements, the radius of the elements changes. That means a is variable, remaining does not change. So this is equal to 2 pi sigma is constant into integral a cube dA. Limits small a is equal to r to capital R. Okay. Therefore, I is equal to 2 pi sigma into, here integral a cube dA means a to the power of 4 by 4, limits small r to capital R. So 2 pi sigma by 4 you write outside into, instead of a substitute capital R to the power of 4 minus small r to the power of 4. When you substitute lower limit, we had put minus sign. Now we substitute the data. 2 pi by 4 into sigma means m by this one. M by pi into capital R square minus small r square. Here this can be written as r square minus small r square into r square plus r square, we can write now. R square minus small r square into r square plus small r square. A plus b into a minus b we can write. This r square minus small r square, this one cancel, pi cancel, 2 2s are. Therefore, I is equal to m into capital R square plus small r square whole by 2. This is the moment of inertia of the angular disk with inner radius smaller and outer radius capital R. So, yeah, m by 2 into capital R square plus small r square. That is the moment of inertia. Okay, in this way we have to do. I think you could follow. No, surface density is generally formula. No, surface density is called mass by area. Area of material of the disk means pi into capital R square minus small r square only. No, we are not remembering the formulas. Surface density means definitely that is fixed formula, mass by area, that is formula. In this case, what is the area means pi of r square minus small r square. Here not remembering these formulas. If you are remembering the formulas, what is the need of making videos personally? Okay, just I say the formula for this is this one, formula for that one that is. So in this way we can say, but we need the concept, no? Because in especially for mains it is okay, but advanced it is not okay. In advance, based on that concept, we should do the problem. In such cases, it becomes difficult if you don't know the concept. Okay, right. Okay, we'll do problems now. Some problems we'll do based on the moment of inertia concept. Based on the moment of inertia concept, we had to do the problems. In page number 98, lecture sheet, all of you see the problems. Already yesterday I have given some problems to you. So in lecture sheet, exercise 1, level 1, page number 98. Okay, here, which problem you need? I think first problem, second problem you can do. I think you did the problems. Okay, while explaining on the board, I will stop the video sharing so that every people can watch the solution. Okay, right. Which problem you need? In the above problem, moment of inertia of system about z-axis passing through center is. Maheshwar Reddy, you asked second problem. Is page number 98 or not? I think it is. I think this is in practice sheet. No, I think these are the problem. Okay, these are in practice sheet. Okay. Now you see. Okay, now you see lecture sheet. In lecture sheet, which problem you need? In lecture sheet, which problem you need? Page number 98. Which problem you need? I think first problem, okay. First problem is direct problem only. Figure shows the square with point masses m at corners. Moment of inertia about x-axis passing through the center and moment of inertia of the system about y-axis passing through center. Both are same, no? First problem you see. In first problem, there is a square frame. 4 particles are kept, 4 identical particles each of mass m say. They are kept at the 4 corners of the square. This is the center. Here it is x-axis passing through center, y-axis passing through center, means these are the x and y-axis, no? X-axis, y-axis. About this axis or about this axis, as the particles are symmetric, moment of inertia is same. So about x-axis, what is the moment of inertia? Or about y-axis, what is the moment of inertia? Means you see about this axis, mass into distance square, mass into distance square, mass into distance square, mass into distance square. As it is the bisector, definitely this distance are same. These distance are also same. For one particle, what is the side here? Side is L. That's why this distance is equal to L by 2. So mass into L by 2 whole square. L by 2 whole square. It is the moment of inertia of one particle about this axis. All particles are having same masses, same distances. 4 particles are there like this. Into 4 you write, that's all. That is equal to ml square only, no? Similarly about y-axis also, you will get the same particles, same distances. That's why you'll get same formula. That's why ix is equal to iy is equal to ml square. This is only formula. Next, in another problem, next problem they asked about this axis, they asked the moment of inertia. About z-axis. About z-axis, they asked the moment of inertia. Or about an axis passing through center of the frame and perpendicular to its plane. That means about this axis, what is the moment of inertia? Means from this axis, each and every particle is at this distance, no? At this distance, if it is L by 2, definitely this is also L by 2. Then what about this distance? Root 2 into L by 2. This distance is equal to root 2 into L by 2. That means L by root 2, no? This distance is L by 2. So moment of inertia of this particle about z-axis is equal to m into L by root 2 whole square. In this way, all 4 particles are at the same distance. So m into L by root 2 whole square into 4. That is the moment of inertia of the 4 particles about this axis. What is the radius of gyration about this axis? Means about this axis you find the moment of inertia, that is equal to mk square. M means mass of the system into k square. Mass of the system means about this axis as moment of inertia is found for 4 particles. Mass of the 4 particles is 4m into radius of gyration square. K can be calculated. Okay. Distance from origin means distance from the axis, from the origin only. That is equal to L by root 2, no? Okay. Next, you see the problems and which problem you need. You ask me immediately. Up to 5, you see which problem you need. Third problem. Okay. Third problem you see. Third problem. 4 rods of equal length L and mass M each form a square as shown in the figure. Moment of inertia of the system about the axis 1, 2, 3. By means of 4 rods, a square frame is formed. This is one rod, this is another rod, this is another rod. In this way, by using 4 rods, a square frame is formed like this. A square frame is formed like this. Okay. Side is L. 4 rods are having same mass M and length is L. All rods are having M mass each M and length L each. The moment of inertia of the system about the first axis. First axis is this one. First axis is this one. Second axis is this one. Third axis is this one. So about this axis, whatever the moment of inertia, you see, first about first axis means, you see, I1 is equal to, for this axis, this is the axis passing through midpoint of this rod and perpendicular to its length. Passing through midpoint and perpendicular to length. Moment of inertia is m into L square by 12, no? ml square by 12. Moment of inertia of this rod about this axis is ml square by 12 because it is the axis passing through midpoint perpendicular to length. That's why moment of inertia about an axis passing through midpoint perpendicular to length means ml square by 12. Say here this rod also like this only. That's why into 2 plus these two. For these 2 rods we have written the moment of inertia about this axis. For the remaining 2 rods, here this rod, you see every part of this rod is equidistant from this axis, no? That's why this entire rod can be treated as a point mass here. Then moment of inertia of this mass about this axis is mass into distance square. This distance is L by 2 only, no? This is L by 2. From this axis, this is at a distance L by 2. That's why L by 2 whole square. It is the moment of inertia of this rod. Similarly, for this rod also at the same distance L by 2. That's why into 2. You simplify them. Then you will get, I think 2 by 3 ml square you will get. 2 by 3 ml square you will get. Okay, this is I1. Next, about this axis, what is the moment of inertia? I2 is equal to question mark. You see, as this axis, about this axis, this rod is not having any moment of inertia because it is a thin rod. It is the thin rod. Due to about this moment of inertia is not there because thin rod means parallel to length of the rod. Moment of inertia is not there for this because distance of this rod from the axis 0 only. It is not the cylinder. It is only thin rod. That's why as this axis passing through thin rod only, moment of inertia is 0. Okay, for this it is 0 plus for this rod. Here this is the axis passing through one end and perpendicular to length. That's why moment of inertia about this axis passing through one end perpendicular to length of the rod is ml square by 3, no? ml square by 3. In this way, this rod is also there. That's why into 2 plus this. For these 2 rods it is over. For this rod is also over. For this rod, every part of this rod is equidistant from this axis. That's why this can be treated as a point mass here m, and distance is this is equal to L. That's why m into distance square, L square. So when you simplify them, then you will get 5 ml square by 3, no? 5 ml square by 3. ml square by 3. It is the moment of inertia about the second axis. About the third axis, that is very simple. About the third axis, moment of inertia is, you see, this rod makes an angle as it is a square and it is a diagonal, then it makes an angle 45 degree, no? So about an axis passing through one end of the rod and makes an angle theta with this rod. What is the moment of inertia? ml square by 3 into sine square 45. I think we derived yesterday. Yesterday we derived the formula for that. What is that formula? Yesterday we derived sine square theta or sine theta? Sine square theta or sine theta? Sine square theta only, no? ml square by 3 into sine square theta. So sine square theta. It is the moment of inertia of this rod about this axis. For this also same, no, because it is also 45. For this also same, because about this axis, this rod also makes 45. This rod also makes 45. That's why into 4 you write. That's all. You will get answer directly. So 4 into ml square by 3 into sine square 45. That is equal to ml square by 3 into 4 into sine 45 means 1 by root 2, square means 1 by 2. 2 2s are. Therefore, I3 is equal to 2 ml square by 3. 2 ml square by 3. Okay. This is the formula. I think 2 ml square by 3 means first option is correct. Option 1 is correct. Option 1, that is correct. In this way, you have to do. I1, I3 equal. What is I1? Yeah, I1, I3 are equal. I1, I3 are equal. Right. Next, which problem you need? In level 2, you see, level 2. In level 1, I think completed. Okay. In level 2, you see. In level 2, Varshit Reddy, in level 2 or level 1? Varshit Reddy. In level 2, fourth problem. Level 1 or level 2? Fourth problem. In which exercise you ask? In which level you asked fourth problem? Level 1. Okay, in level 1, fourth problem. Okay, I will explain. It is very, very important problem. This is very, very important problem. Okay. Shall I erase this one? Shall I erase this one? Okay. Next, in level 1, fourth problem. Okay. Fourth problem, you see. A thin rod of mass 6m and length 6l is bent into a regular hexagon. The moment of inertia of the hexagon about normal axis to its plane and through center of the system. Okay. One thin rod of mass 6m and length 6l, that is bent in the form of regular hexagon. Hexagon means 6 sides are there, no? All are having same sides. Like this. So this side, as 6 sides are there, the mass is distributed equally. That's why this side is having mass m like this and length L, because 6 sides are there, 6L. About an axis passing through center and perpendicular to this one. What is the moment of inertia? About this axis, they asked the moment of inertia. So to find the moment of inertia about this axis, first you find the moment of inertia of one side about this axis. Then remaining are all are same. That's why into 6 you write. That's all. So moment of inertia I is equal to 6 into moment of inertia of this rod about this axis. Already the center mass of this rod lies exactly at the center, no? Center mass. Parallel to this given axis passing through center mass, we know the moment of inertia, that is ml square by 12, no? ml square by 12 plus m into this distance square. What is this distance? This is L. Okay, this is L. This is L. Because all sides are L like this. L, this is L. What about this distance? That is equal to, you see, this is L by 2, this is L. Then what about this distance? That is a smaller. From the diagram, what about smaller? Root of L square minus L by 2 whole square. Root of L square minus L by 2 whole square. That means root 3L by 2, no? Therefore, about this axis, moment of inertia means you apply the parallax theorem, Iz plus M into R square. So this is equal to, for 6 rods, you can do the moment, we can find the moment of inertia like this only. That's why into 6 we write, because all the rods are identical now about this axis. That's why 6 into, all the rods are symmetric about this axis. Due to one rod, you find the moment of inertia about this axis, and into 6 you write. That's all. Iz means parallel to this axis passing through center mass, moment of inertia is ml square by 12. So ml square by 12 plus m means mass of this rod, small m, into this distance square means root 3 by L by 2 whole square. So this is equal to, therefore I is equal to 6 into ml square by 12 plus here m into 3L square by 4. That means 3 ml square by 4. Take LCM. 12. So this is ml square plus 4 3s are, that means 9 ml square. Therefore 6 2s are 5 ml square you will get now. So moment of inertia of the system about this axis is 5 ml square. Yeah, 5 ml square. Okay. Okay, right. Sahit, stop your video. Sahit, Harishankar. Right, Nana. Okay, next in level 2. In level 2, which problem you need? In level 2, which problem you need? Third problem in this only. In this only you need third problem. Satvik. In level 1 third problem or level 2 third problem? Satvik. Okay, I will share the screen. Level 2. Okay, level 2 third problem. Uday Krishna. Fourth problem in level 1 or level 2? We are doing problems in level 1 only first. Level 1 is over. Okay. Now level 2. Okay, all of you see the level 2. Okay, now all of you see the level 2. In level 2, what about 1? What about problem 1? What about problem 1? In level 2, problem number 1. Cross means perpendicular. Two thin uniform rods, each of mass m and length L, are arranged to form a cross. Cross means perpendicular. Plus shape. Plus shape is called cross. The moment of inertia of the system about an angular bisector. Okay. Here in level 1, you see in level 1, problem number 5. Somebody asked me. Here, fifth problem, two uniform rods, each of mass m and length L, are arranged to form a cross. Cross means perpendicular. This is one rod. This is another rod. Two rods are kept perpendicular to each other. Then only these two are said to be arranged in the form of a cross like this. Okay, now what is the moment of here? Mass of each rod is m. Mass of each rod is m and length is capital L. Okay, then moment of inertia of this arrangement about an angular bisector. About an angular bisector means you take angular bisector. This is the angular bisector. Angular bisector means definitely it is 45 now. About this axis, what is the moment of inertia of the system? Already previously we done in case of square. This is also same. I is equal to moment of inertia of this rod about this axis is, it is the axis passing through midpoint and makes an angle theta with rod now. Then moment of inertia is ml square by 12 into sine square theta means 45 degree. It is for one rod. The other rod is also at the same angle, no? Same mass, same length. That's why into 2, you will get answer. So I is equal to ml square by 6, because 2 6 are, into 1 by root 2 whole square means 1 by 2. That is equal to ml square by 12, 12 only, no? ml square by 12. That is the answer. Okay. Right. Now, in level 2, you see in level 2, which problem you need? In level 2, which problem you need? A quarter sector is cut. Okay, that is important problem. Already in video, I made a video. You see, in level 2, I made a video also. Okay, in level 2, page number 98 only, problem number 1. A quarter sector is cut from a uniform circular disc of radius r. This sector is having mass m. It is made to rotate about a line perpendicular to its plane and passing through center of the original disc. The moment of inertia of the about this axis of rotation. Here, this is the sector. It is the sector. Side view of the sector is this one. Mass m and radius capital. About an axis passing through center and perpendicular to the sector. What is the moment of inertia? They asked. I. Okay. So here, if mass of the sector is given as m and radius is r, moment of inertia is equal to mr square by 2 only. Just like the, suppose if there is a circle disc is there, it is a part of the disc only, no? If the disc is there like this, about an axis passing through center and perpendicular to plane of the disc, what is the moment of inertia means? If m is the mass of the entire disc, moment of inertia is mr square by 2 only. For the sector also, if the mass of the sector is given, then moment of inertia about this axis passing through center and perpendicular to plane of the sector is equal to m square by 2 only, same formula. But here in this formula, m is the mass of the sector, not disc. Okay, same formulas. How we can find? Suppose you feel, if m is the mass of the sector, which makes an angle theta at the center, then the mass of the entire disc is say m naught. Mass of the entire disc is say m naught, which makes an angle 2 pi radians at the center. Mass of the disc means, mass of the disc is m naught, say. This entire disc makes an angle 2 pi radians at the center, no? For 1 radian, what is the, for 1 radian, what is the mass? Mass per 1 radian is this one. Mass of the circular disc which makes an angle 1 radian at the center is equal to m naught by 2 pi. For this angle, what is the mass? Means into theta naught. That is given as capital. ఇక్కడ 2 pi రేడియన్స్ యాంగిల్ చేసే ఈ డిస్క్ యొక్క మాస్ క్యాపిటల్ అయితే 1 రేడియన్ యాంగిల్ చేసే సెక్టార్ యొక్క మాస్ ఎంత అంటే m naught by 2 pi. థీటా యాంగిల్ చేసే సెక్టార్ యొక్క మాస్ ఎంత ఇంటూ థీటా. దిస్ ఈస్ ద మాస్ ఆఫ్ ది సెక్టార్ which is given as m. Implies m naught is equal to, we can write 2 pi m by theta, no? It is the mass of the entire disc. So what is the moment of inertia of the entire disc about this axis? Moment of inertia of the entire disc about that axis is equal to m naught into m r square by 2, m naught into r square by 2. It is the moment of inertia of the entire disc about this axis, where m naught is the mass of the disc about the mass of the disc, r is the radius. It is the moment of inertia of the entire disc, but we need the moment of inertia of this part only. It is the moment of inertia of the entire disc which makes an angle 2 pi radians at the center. Then what is the moment of inertia of the sector which makes an angle 1 radian at the center means by 2 pi. 2 pi radian angle చేసే entire disc యొక్క moment of inertia about this axis ఇంత అయితే 1 radian angle చేసే సెక్టార్ వలన moment of inertia ఎంత అంటే m naught r square by 2 by 2 pi. మరి theta angle చేసే సెక్టార్ యొక్క moment of inertia ఎంత into theta. That is I. This is we need. Now we substitute the data. M naught means, okay, here we can write m naught r square by 4 pi into theta. Okay, this I is equal to m naught means how we can write m naught? 2 pi m by theta. So 2 pi m by theta you write into, instead of m naught I have written this one because m is given, not capital M naught, r square theta by 4 pi theta cancel, pi cancel, 2 2s are, therefore I is equal to mr square by 2 only, no? So better to remember this formula. Already I made the video, afternoon I will upload. Okay. Okay. So here for the sector, what is the moment of shape they ask? It is a part of the disk only, no? That's why if m is the mass of the sector here, what is the mass of the entire disk? That is say m naught. This entire disk having mass m naught makes an angle 2 pi at the center. Then what is the mass of the sector which makes an angle pi 1 radian at the center means m naught by 2 pi. Then what is the mass of the sector which makes an angle theta at the center means into theta. 1 radian ki inta mass unte theta angle chese sector యొక్క mass enta ante into theta, that is given as m. Therefore from this mass of the entire disk is equal to 2 pi m by theta, no? Because when you know the mass of the entire disk about this axis, we know the formula for moment of inertia, mr square by 2. That's why moment of inertia of this entire disk about this axis mr square by 2. Okay. So this moment of inertia of the entire disk about this axis which makes an angle 2 pi at the center. For 1 radian angle, what is the moment of inertia means this by 2 pi. For theta angle, for the sector makes an angle theta at the center, what is the moment of inertia means into theta. M naught value substitute here, simplification gives mr square by 2. Kabatti sector kaina disk kaina sare, whatever the angle made by the sector at the center, the moment of inertia about an axis passing through center and perpendicular to plane of the sector, moment of inertia is formula for moment of inertia is same as that of the disk only, but here in this formula m is the mass of the sector only, not entire disk. Okay, that is the formula. I is equal to ఎలా తీసుకోవడం అమ్మా ఇక్కడ I is equal to చూడండి I is equal to మొత్తం డిస్క్ యొక్క మూమెంట్ ఆఫ్ ఇనర్షియా తీసుకున్నా. డిస్క్ యొక్క మూమెంట్ ఆఫ్ ఇనర్షియా అంటే మాస్ ఆఫ్ ది డిస్క్ ఇంటూ r స్క్వేర్ బై 2 నే కదా. డిస్క్ యొక్క సెంటర్ గుండా పాస్ అవుతూ ప్లేన్ కి పర్పెండిక్యులర్ గుండా యాక్సిస్ పరంగా మూమెంట్ ఆఫ్ ఇనర్షియా అంటే m స్క్వేర్ బై 2 నే కదా. అబౌట్ an axis passing through center perpendicular to the plane of the disk, moment of inertia is m square by 2 only. Mass of the disk is taken as m naught, that's why m naught r square by 2. But this disk makes an angle 2 pi radians at the center. For 1 radian, if the sector makes 1 radian angle at the center, what is the moment of inertia means this by 2 pi. For theta angle, what is the moment of inertia into theta? I substituted m naught value from this. I got this one simply. Okay. Some fundamentals we have to remember. About natural axis, what is the moment of inertia? About the diametric axis, what is the moment of inertia? Some fundamentals we have to remember the formulas. For remaining, by applying parallax theorem or perpendicular axis theorem, we can write the formulas. Okay. Right. Next in level 2, what is the problem you need? In level 2, already second problem I said. What about the third problem you see? What about the third problem? You see third problem in level 2. What about the third problem in level 2? You see. Okay, third problem I will explain because I did not give this problem as homework. I will explain third problem. Because the third problem is important for advance also. Third problem. All of you read that problem. A uniform circular ring of radius capital lies in xy plane with its center at origin. Its moment of inertia about an axis lying in xy plane parallel to x-axis and passing through a point on the y-axis at a distance y is equal to 2r is I1. Moment of inertia about an axis lying in a plane perpendicular to xy plane passing through a point on the x-axis at a distance x is equal to d. I think it was given once in advance. It was given in advance once. Okay. If I1 is equal to I2, what is the value of d? Okay, I will draw the diagram first. You see, all of you. It is very, very important problem for advance especially. A uniform circular ring of radius capital lies in xy plane. Suppose plane of the board is in xy plane, you take, because in order to understand the diagram clearly, you take like that. This is the circular ring. This is the circular ring of radius capital. Of course, radius is capital. Radius is capital. Uniform circular ring of radius capital lies in xy plane with center at the origin. Suppose this is x-axis, this is y-axis. The center of the ring is at origin according to the problem. That's why we take this as origin. This is negative x-axis, this is negative y-axis. It is x-axis, it is y-axis. Okay, I have taken like this. Now, it's a moment of inertia about an axis lying in xy plane parallel to x-axis and passing through a point on the y-axis at a distance 2r. This is equal to r only, no? 2r means definitely that point lies somewhere here. About this axis, moment of inertia about an axis passing through a point in y-axis parallel to x-axis at a distance 2r from the origin. Here you see, it's moment of inertia. That means moment of inertia of the ring about an axis lying in xy plane. This line also lies in xy plane only, no? Passing through a point on the y-axis. On the y-axis, this line passing through a point. Passing through a point lying in the xy plane parallel to x-axis. This line is parallel to x-axis. Passing through a point on the y-axis at a distance y is equal to 2r. This is y is equal to 2r. Y is equal to 2r. Okay. Is I1. About this axis, moment of inertia of the ring is given as I1. Tell me I1, how we can write I1 first? I1 is equal to, tell me. Here, about this axis, we know the moment of inertia, no? Because in case of ring, it is the center mass of the ring is say capital M. So this is the center mass or center of gravity of the ring, no? About an axis passing through center of mass. About this line, we know the moment of inertia because it is the diametric axis of the ring, which is parallel to this one. So moment of inertia about this axis. Moment of inertia about this axis is the axis passing through center mass parallel to this axis. So we apply the parallax theorem. According to parallel axis theorem, I1 is equal to Iz plus mr square. Iz plus m into r square. So that is equal to Iz means parallel to this axis passing through center mass. About this axis, what is the moment of inertia means? It is the diametric axis, no? About the diametric axis, what is the moment of inertia of the ring means? Mr square by 2 plus m into perpendicular distance between these two parallel axis square means 2r whole square. 2r whole square. Okay. Therefore, I1 is equal to what you will get? 9 mr square by 2, no? Because it is 4 mr square. When you take LCM, 8 mr square plus mr square, 9 mr square by 2. This is equation 1. Next, you read the another part. It's the moment of inertia about an axis lying in the plane perpendicular to xy plane, passing through a point on the x-axis at a distance x is equal to d. So here, perpendicular to xy plane. Perpendicular to xy plane means, suppose here this is the z-axis. Perpendicular to xy plane, passing through a point at a distance x is equal to d from the origin. Perpendicular to xy plane and passing through this point. Perpendicular to xy plane and passing through this point means that is parallel to z-axis, no? About this axis, moment of inertia is I2. So how we can write I2? I2 is equal to, you see, parallel to this axis, passing through center of mass. We know the moment of inertia, no? Parallel to this axis, passing through center of mass of the ring means that is the natural axis of the ring. About that axis, we know the moment of inertia. Okay, that's why we can apply the parallax theorem for this also. According to parallax theorem, Iz plus mr square general formula. So I2 is equal to, parallel to this axis passing through center of mass, Moment of inertia means about z-axis they ask the moment of inertia. That is equal to mr square only, no? So about an axis passing through center perpendicular to plane of the ring, moment of inertia is mr square. In case of ring, plus m into r square means d square. This is d. That's why d square. Of course, this distance is r. R is equal to d square. R is equal to d. So d square means that may be lies inside the ring or outside the ring, whatever it may be, d square. So, okay, you keep like this only. This is equation 2. If I1, I2 are equal, then what about the d value? That is the question. As I1, I2 are equal, you make them equal. I1 means 9mr square by 2. I2 means mr square plus m into d square. So in all we can cancel m. Then d square is equal to r square 9r square by 2 minus r square. You bring this r square to left. Then it is equal to 7r square by 12, no? 2, no? Therefore, d is equal to root 7 by 2 into r. So d is equal to root 7 by 2 r. That is the answer. Yeah, root 7 by 2 r. That is the answer. Okay. Next, which problem you need? Next, fourth problem. Okay, now you see the fourth problem. Third problem was completed. This is very, very important. Next, fourth problem. That is also, that model is also important because once it was given in advance. Fourth problem you see. I of cylinder. Okay, I will explain cylinder. Okay, first I will explain in case of, is it cylinder? It is circular plate only, no? Where is the cylinder? Cylinder is not here. Okay, I will explain anyhow. In case of cylinder, okay, shall I explain cylinder first or shall I explain the problems now? Okay, now fourth problem you see, that is important. Fourth problem, all of you see the fourth problem first. See the fourth problem. A circular plate of radius r by 2 cut from one edge of a thin circular plate of radius r. The moment of inertia of the remaining portion about an axis through O perpendicular to the plane of the plate is. Here, fourth problem in level 2. This is the circular plate. It is the center O. A circular plate of radius r by 2 is cut from one edge of the thin circular plate. So from the circular plate, from the edge of the circular plate, one circular plate of radius r by 2 is removed from the edge. For the remaining portion, about an axis through O perpendicular to the plane of the plate, what is the moment of inertia? M is the mass of the remaining circular plate. Okay. Mass of remaining plate is equal to capital M. That is given. Okay, now all of you look at the board. It is very, very important problem. Okay, all of you see the board. Here, actually, we are given one circular plate or circular disc. From that circular disc of radius capital R, mass of the disc is not given. Mass of the entire disc is not given, but one circular plate is given whose radius is capital R, from which a small disc of radius r by 2 is removed from periphery or from the edge. ఈ సర్క్యులర్ ప్లేట్ యొక్క ఎడ్జ్ దగ్గర నుంచి స్మాల్ r by 2 రేడియస్ కల ఒక స్మాల్ సర్క్యులర్ ప్లేట్ ని రిమూవ్ చేశాడు. r/2 radius అంటే diameter r కాబట్టి డెఫినెట్ గా the other edge of the removed part passing through center no ఈ రేడియస్ కల్ r/2 రేడియస్ కల్ పార్ట్ ని రిమూవ్ చేశాడు. ఫర్ ద రిమైనింగ్ పార్ట్ మాస్ ఇస్ m. దెన్ వాట్ ఇస్ ద మూమెంట్ ఆఫ్ ఇన్షియా ఆఫ్ ది రిమైనింగ్ పార్ట్ అబౌట్ ద సేమ్ యాక్సిస్ i ఈజ్ ఈక్వల్ టు క్వశ్చన్ మార్క్. అయితే ఇక్కడ ఏం చేద్దామంటే ఫస్ట్ మూమెంట్ ఆఫ్ ఇన్షియా ఆఫ్ ది ఎంటైర్ సర్క్యులర్ ప్లేట్ వితౌట్ రిమూవల్ ఆఫ్ ది స్మాల్ పార్ట్ అంటే టోటల్ డిస్క్ మూమెంట్ ఆఫ్ ఇన్షియా ఆఫ్ ది డిస్క్ వితౌట్ రిమూవల్ you find the moment of inertia of the entire plate about this axis without removal of the part. From that you subtract the moment of inertia of the removed part about this axis. I removed. You find. Then that gives the moment of inertia of the remained part. Okay. So here you see, in fourth problem, we are given one circular disc of radius capital R, from which a small circular disc of radius r/2 is removed from the edge. The remaining part of the disc is having mass m. Then what is the moment of inertia of the remaining part about the axis passing through center O perpendicular to the plane of the disc, perpendicular plane of the plate. About this axis, they asked the moment of inertia. First, you feel that there is entire disc, no removal of the small part. Total disc is there having mass say m0. Then you find the moment of inertia of that entire disc about this axis. That is the moment of inertia without the removal part. Okay, that means without removal of this part, you find the moment of inertia of the disc about this axis. From that moment of inertia of this part you subtract. Then that gives the moment of inertia of the remaining part. Okay, in order to find the moment of inertia of the entire total disc, we need the mass of the entire disc. No, we are given mass of the only this part of the disc only, remained part only. So suppose the mass of the entire part, if mass of circular plate, mass of plate without removal is equal to say m0. Without removal is equal to say m0. How we can find this mass? If you know that mass, we can write this formula. Okay, we can find the moment of inertia of the removed part also very easily. How we can find the mass of the entire disc without removal of mass in terms of this m? Because m0 we imagine m is given by them. As it is a circular plate, definitely mass resides only on the surface. No, mass distributes uniformly entire its area. No, that's why if m is the mass of the remaining part, then what is the surface density? Because surface density is same for everyone. Surface density is equal to mass of the given remained part by area of the remained part. What is the area of the remained part? From the total area of the circular plate, you subtract the area of this small plate removed. Total area is pi capital R square. From this, pi into r/2 whole square is the area of the removed part. So sigma is equal to m by pi r square minus pi r square by 4. Therefore, you will get that is equal to sigma is equal to 4m by 3 pi r square. This is equation 1. It is the mass per unit area. That is the surface density. Therefore, what is the mass of the entire circular plate? Mass of the entire circular plate m0 is equal to surface density. That means mass per unit area into area of the entire disc is equal to pi r square. No, pi r square. That is equal to sigma. Sigma means 4m by 3 pi r square into pi r square. So pi r square cancel. Therefore, m0 is equal to 4m by 3. It is the mass of the entire disc before this part is removed. Okay, what is the mass of the removed part? Mass of the removed part we need to find the moment of inertia of the removed part. Mass of the removed part means surface density into area of the removed part. Area of the removed part is equal to pi into r/2 whole square only, no? So sigma means 4m by 3 pi r square into r square by 4. 4 cancel, r square cancel. No, here pi is there, no? Pi cancel. Therefore, m is equal to m by 3. M by 3. Okay. So this is equation 3. Now you write from this equation 1, I remained is equal to, tell me, what is the moment of inertia of the entire disk without removal of the small part? Without removal of the small part, mass of the entire disk is equal to capital M naught. So moment of inertia of the circular plate about this axis is equal to mr square by 2 only, no? M means m naught into radius square by 2 minus mass of the moment of inertia of the removed part means, you see, for this removed part about the same axis, moment of inertia of the removed part means this is the axis passing through one edge. That means it is a tangential axis perpendicular to plane of the plate. Perpendicular to plane of the plate. Moment of inertia about this axis we had to find. Parallel to this axis passing through center of mass of this removed part. We know the moment of inertia, Iz. Okay. Then about this axis, you apply the parallax theorem and write the moment of inertia about this axis for this removed plate. Moment of inertia of the removed part about the natural axis parallel to about the axis parallel to given axis passing through center of mass is equal to mass of this part into radius mr square by 2. So mass of the removed part is small m into radius r by 2. Of course, small r you write small r square by 2 plus m into distance between these two parallel axes. That means r by 2 only. R by 2 whole square. That means r square by 4. Okay. This is equal to m naught r square by 2 minus, here you see, m by 2 into small r means capital R by 2, whole square means r square by 4 plus mr square by 2. Sorry, mr square by 4. So now you substitute the data. M naught means 4m by 3. 4m by 3 into r square by 2 minus, here mr square by 8 plus mr square by 4. This is equal to, here when you simplify them, 2 mr square by 3 minus, when you take LCM, you will get 3 mr square by 8, no? Because mr square plus 2 mr square, when you take LCM, that means 3 mr square by 8. But m, we imagine, capital M is given by them. So in terms of capital M, we have to write 2 mr square by 3 minus 3 by 8 into, what is small m? Small m is equal to m by 3. You write m by 3 into capital R square. 3 cancel. So this is equal to 2 mr square by 3 minus mr square by 8. Again you take LCM. 24 is the LCM, no? Then 3 8s are 8 into 2, 16. 16 mr square minus 8 3s are 3 mr square. That is equal to 15 mr square by 24. Okay, no, sorry, 13 mr square by 24. So 13 mr square by 24. Yeah, that is only answer. So I remained is equal to 13 mr square by 24. It is the answer. 13 mr square by 24. Okay, that is the answer. I think sixth problem in this I said. Next, fifth one, very, very important. I want to say here only. Fifth problem. Atla, we should not do like that. We should not do like that. Moment of inertia only we have to subtract. Okay. Here for small m we can write. For small m, from the total mass 4m by 3, we had subtract capital M. From total mass 4m by 3, when you subtract this part mass m, then you will get this one. We can do like that. Small m means mass of this part means surface density sigma into area of this small part, that is equal to pi into radius square r by 2 whole square. Okay, Pawan. Okay, Pawan. Right. Next problem you see, fifth problem I want to explain. Sixth problem already I said previously. In concepts only I said. Okay. Now all of you see the fifth problem. All of you see fifth problem. Okay, have you seen the problem? Okay, now a uniform disk of radius 8 cm lies in xy plane with its center at origin. Its moment of inertia about z-axis is equal to moment of inertia about a line 4y is equal to 3x plus 4c, where c is constant. Find the value of c. Tan 37 is equal to 0.75. Okay, now all of you see the problem. All of you see the board now. Time is 1 minute is there now. Okay, can you spend Can you spend 5 minutes? I will explain. Otherwise, I will stop now only. Shall I stop or can you spend 5 minutes? Okay, I will upload in the YouTube. Right, you see. A uniform disk of radius r is equal to 8 cm lies in xy plane. Lies in xy plane with its center at the origin. There is a circular disk. There is a circular disk whose radius is given. Radius r is equal to 8 cm given. This lies in xy plane with center at the origin. So this is x-axis, this is y-axis. So it is origin. It is x-axis, it is y-axis. Okay, it is origin. Okay, its moment of inertia about z-axis is equal to. So moment of inertia about z-axis means this is the z-axis now. About this z-axis, moment of inertia is, that is given. Moment of inertia about z-axis is equal to, what is the moment of inertia about z-axis? Suppose mass of the disk is say capital M, then moment of inertia about z-axis means it is the natural axis of the disk now. It is the axis passing through center perpendicular to the plane of the disk, because the plane of the disk lies in xy plane. So that is equal to mr square by 2 only, no? Mr square by 2. You keep like this. It is the moment of inertia about z-axis. Okay, that is equal to moment of inertia about a line 4y is equal to 3x plus 4c. That is one straight line. That is one straight line. 4y plus 3x, 4y is equal to 3x plus c. That is one straight line. Okay, suppose that straight line lies here. That straight line lies in xy plane only. So that is the straight line lies here. This is equal to 4y is equal to 3x plus 4c, or 3x minus 4y plus 4c is equal to 0. Ax plus by plus c is equal to 0. In such a way, that is a straight line equation. One straight line is there. About this straight line, the moment of inertia of the this disk, that is same as moment of inertia of the disk about z-axis. That is a question. Okay. Here, what is the slope of the straight line? What is the slope of the straight line? Slope of the straight line means angle made by the straight line with x-axis we have to find. Angle made by the straight line with x-axis we have to find. Okay, then we have to apply the parallaxes theorem. What is the perpendicular distance of the straight line from the origin? From this origin, from the center or origin, you draw a perpendicular line. Perpendicular distance of the straight line from the center is already, by using this formula we know. Okay, therefore small r is equal to, tell me, small r is the perpendicular distance of the straight line from the origin. Okay, that is equal to, tell me, c by square root of a square plus b square. Now c means 4c by a square means square root of 3 square plus b square means 4 square. Because ax plus by plus c is equal to 0. No, c means 4c, a means 3, b means 4. So 4 square. That is equal to 4c by 25 means 5. No, 4c by 5. Perpendicular distance is this one. About this about this axis, we need the moment of inertia. Parallel to this axis, parallel to this line, passing through center of mass, we know the moment of inertia. About this axis, moment of inertia, say Iz. Then about this axis, moment of inertia is, say, I dash. So I dash is equal to moment of inertia of the disc about this card lies along this straight line is equal to Iz plus mr square according to parallax theorem, m into small r square. So Iz means moment of inertia of this square plate, circular plate, parallel to this straight line passing through center of mass is equal to Iz means mr square by 4. No, it is the diametric axis. No, that's why mr square by 4 plus m into r square means this one, 4c by 5 whole square. Okay, this is the moment of inertia. But according to the problem, this is 2. According to the problem, these two are equal. Therefore, Iz is equal to I dash. Iz means mr square by 2 is equal to, here it is mr square by 4 plus m into 16c square by 25. Okay, therefore you bring this to left and you take you subtract them, then you will get mr square by 4 is equal to m into 16c square by 25. M cancel. Okay, therefore c square is equal to, you write c square is equal to 25 by 64 into r square. R c is equal to 5 by 8 r. Okay, but r is given, the radius is 8 centimeter. Therefore c is equal to 5 by 8 r. R means 8. Since r is equal to 8 centimeter given, so c is equal to 5. No, c is equal to 5. C is equal to 5. But here c square is equal to this one. C can be taken as plus or minus, because c square is equal to, c is equal to plus or minus, you write, because square root of this one, now we can write plus or minus. Therefore c is equal to plus or minus 5 centimeter we can write. So this is the problem. So it is also one important problem for advance. Okay, why mr square by 4 means, again you are coming back to the original points. In case of circular disc about an axis passing through center and perpendicular to the plane of the disc, moment of inertia is mr square by 2 only. No, about the diametric axis, moment of inertia is mr square by 4. No, just before starting the class here today, just at the beginning of the class, I said these formulas only. By using parallax theorem, perpendicular axis theorem, how you can find the moment of inertia, already I explained first. Okay, today you see videos, then you know the formulas. So you have to remember the formulas first. You practice the formulas, then you can do the problems easily. Okay, right. What I want to read? You ask me what you ask me to read? Vashid Reddy, what is your doubt? Here about this straight line, what is the moment of inertia? They asked. Parallel to the straight line passing through center. Because the straight line lies in xy plane means this is the chord of this disc. Parallel to this chord passing through center of mass or center of gravity, it is a diametric axis. No, about this axis, moment of inertia is known, that is mr square by 4 in case of disc. Okay, here parallax theorem we apply. According to parallax theorem, Iz means mr square by 4 plus m into this distance square, that means r square. This distance means it is the perpendicular distance of the straight line from the origin. No, that means this one. No, that's why m into perpendicular distance square means 4c by 5 whole square. But according to the problem, about z-axis moment of inertia, about the chord moment of inertia, both are equal. According to the problem, I made equal. Then I got C is equal to plus or minus 5. Okay. Right, and have a nice day. I'm signing out.